I'm going to do something really cheesy to you all. You all probably wouldn't even notice it because I don't think I say anything that's not up to that's. Well, I do kind of start off. Basically, what I'm doing is I'm copying the lesson. I've got about 1,000,000 things to get done this week, as do you. For me, you probably wouldn't get it till Thursday, and I'd say, "Oh, I want this due by Friday, so we can get done with the course." So what I'm doing is I'm just rolling over the assignment from last spring with all the instruction that went with it and all that, and I'm adding this little intro piece. Now, when you go to the first, when you go to this, and this was back in the day when I used to try and upload the videos to Blackboard, and that was always contentious at best. And the more I do these courses, the better I get at learning how to use the system. I don't get better at teaching them. I just get better at using the technology or discovering ways that to use the technology more effectively. Anyway, this lesson is where you first start looking at work and energy type things, which is what we call mechanical work. All right. So I wanted to just explain a few things and then write some notes here because I noticed that I didn't have any notes with this one. Now I do show you how to work the problems on the homework, but I didn't include the notes. I don't think on a in a PDF file type thing. All right. So here's my calculator, just sitting here, nice and at one level. All right. Now, I am doing internal work to hold this up. I mean, because if I tried to hold this up for 20 hours, I'd start to probably get tired. And maybe even 19 hours ago, I'd have been like, I can't do this anymore. I can't, because my muscles are expanding and relaxing to hold this thing up. But mechanical work means if I take it from here and raise it up here, I moved it. I applied a force and moved it a certain distance, and it changed. And it's actually its potential energy, which we'll get into later, changed. It increased. Right now, we're just looking at work equals force times distance. So the amount of work that I did was I took this. Say this calculator weighs or has a mass of 0.2 kilograms, and I raised it, a half a meter. That'd be 0.2 times 0.5, which would give me 0.01 or 1/100th of a joule of work that I did. All right, so what does that look like? And then when you get into the things, the studies, you'll see. So there's three things we're going to look at: force times distance equals work, power equals the amount of work divided by, and then yeah, and then that's it. All right. Okay, so let me write real quick. So here are the big equations. Equations for homework 6. And how to do it. I was just going to slide this over, but I can't help it. I have to. I have to gab. I have to yak. Now you're going to find that I was having some issues, I guess. And when I was watching the movie, I went, "Oh yeah, I remember that." I had to start it over because I dropped f-bombs all over the place while I was trying to do the thing, and that's not good. That's not constructive. Makes me feel better, but it's not constructive. Anyway, equations for chapter 6. The amount of work, this is mechanical work that we do, is equal to the force we apply times the distance. And these are vectors, displacement, but it's in a straight line. So in other words, if I push a box, say with 10 newtons of force, because everything's in, if I push a box with 10 newtons of force across a frictionless table for 5 meters, when it gets to here, the amount of work I will have done would be 10 newtons times 5 meters, which equals 50 Newton meters of work, which is equal to 50 joules. Okay? We'll get into later how work is the change in kinetic energy and all of that stuff. All right? But that's that. Now, if it took me, let's say it took me 10 seconds to do that. If it took me 10 seconds to do that, then the amount of work that I did, the power, would equal the work divided by the time. So if I did 50 joules of work, divide that by 10 seconds, that equals 5 joules per second, or 5.0 watts. Now, an interesting thing, John Watt, the physicist named John Watt, who the watt is named after, actually gave us the old horsepower. And basically what Watt did was, he hooked up an old plow horse there in Scotland. He hooked up a plow horse to a plow and said, okay, take it 100 meters. I'm going to time you how long it takes you to do that. And that's what I'll call a horsepower. That's the amount of the amount of weight that you drug that distance divided by the time we'll call 1 horsepower. All right. We're used to watts in our light bulbs and horsepower in our cars. One watt is equal to 0.0134 horsepower. So horsepower is a much larger unit, like 250 horsepower. So in other words, if I had something that was like kind of a souped up car, 200, because my car's like 150, I think, my Bad Ride Mazda, 150 horsepower, how many watts is that? Well, in this case, I'd take 250 horsepower, and I'm going way off the deep end here. 250 horsepower times how many watts, 1 watt per 0.0134 horsepower to get that to that. Now that's a unit of 1, so to get my horsepower. So if I take 250 divided by 0.0134, yeah, I get about 19,000 horsepower, ballpark. Or not 19,000 horsepower, but 19,000 watts, ballpark. So a 200. Oh, so this is kind of interesting. Now I'm really going off. So that would be divided by 100. A souped up Camaro that goes to it with 250 horsepower is burning about 186 100-watt light bulbs. All right. That's how much power it's doing. Just wanted to do those few calculations for you. This is my intro. Kind of a cheesy way of doing things because I'm just copying something over. It's nothing fresh and new, so I'm not interjecting any new sports things that are going on, which there's a lot of them. By the way, the Chiefs are 1-1 right now. Yesterday's game was like watching a soccer match. We were getting ready for company. We were having my stepdaughter over for her birthday along with my daughter and stuff, and their families. So I wasn't really watching I was cleaning bathrooms. So I was kind of watching the game. I was like, we just can't. 2 great defenses going at it. It was kind of like watching a soccer game. 12, there's 8 field goals kicked in the thing and 1 extra point. So 9 out of the 10 scoring things were done by a kicker. Snoozer. Anyway, they didn't lose bad. I mean, the good thing about it is, I mean, if you're really dying to wool for the Chiefs, the good thing is they played badly and didn't get blown out by a good team. So, of course, the other team wasn't that great either. Anyway, out here,